There's always going to be a need for people to solve the problems that AI is generating, because AI is not going to stop generating problems.
I am doing a lot of work in the education space. And so the argument I'm getting from people is we don't need to learn how to code at all anymore.
This is where I think this conversation gets a little gray. Do you need coding to do these jobs? No. But does coding enhance the outputs of the things that you're able to do? I would say yes.
Anybody that says, oh, you don't need to know how to code, the AI is going to do it, right there, I don't really think they understand it.
All right, welcome everyone. I'm Michael, here with my compatriots in IT and discussion. Gentlemen.
I'm Louis.
I'm Chris McNabb.
We're here on behalf of the Performant Professional to talk about a particular topic today that isn't actually about AI, but don't worry, I'm sure we'll inject AI into it, which is all about like how much software coding skill and what does that even mean do you need in IT to do certain roles? So, I think the first opening question is, and just to scope it out, is that if you're in IT in general, any role, do you need to know how to code?
I mean,
yes.
It depends.
I'm a no. Okay, you're a it depends, and you're a yes. Absolutely. Okay, so let's go one at a time, Louis. Give us the it depends.
I mean, well, let's talk about the scope of what we're talking about for IT, right? So we're talking about people who write code. Obviously, you need to write code in order to do that job. You're talking about people in operations who often need to understand scripting language in order to get things to function or to create automation, but they don't always need to be able to write, Python or in the old days COBOL. Right? You don't need anything. You don't necessarily need that because a lot of the tools can help to bridge some of that gap for you. If you are a Scrum Master or a product owner, you don't necessarily need to have coding knowledge, but it could be helpful, right? That's why I say it depends, is because there are certain roles that require coding as part of their job, and there are other roles which interface with people who do coding. And it might be good to understand at least the high level way that computers operate and the way that they think and how code works and all that other stuff, but it's not a requirement for the job to be successful. That's my opinion.
Okay. So you're saying in general in the all of our IT industry, it's role specific, basically. That's what you're saying.
Yeah, that's what I would say. It would depend on the role and the company you're working for and the requirements for that role.
Okay, but I just want to say this before, Chris, we're going to move on to you, is that the majority of the companies that we're talking about all create software. And I'm talking about the IT departments in particular. In almost every company, they either manage or create software. So I just want to make sure that we're contextually, that's the group we're talking about.
Yep. It hasn't changed my opinion.
So,
Okay, cool. Just make sure. Chris, go.
I mean, if you're describing it as broadly as the IT industry, then no, not everybody needs to code, because there are a lot of jobs that don't necessarily need to code. Such as anybody in product.
But if they're writing software, would it be helpful for them to know how to code?
But they're not writing software. People in product are coming up with ideas for what the software could do. It's the developer's job to tell them whether that is feasible or not.
Ah, okay. Well, so it wouldn't be necessarily helpful then for them to know how to code.
No. I mean, I unless they're going to be doing some of the actual coding work themselves, I don't see that as a necessary thing.
Okay. Keep going.
I would argue that operations people, whether they are writing code themselves or not, really do need to understand code, because very often they're the ones finding the bugs for the devs. It shouldn't be that way, but it is. And an operations person that can, read through other people's code is going to be way better off at troubleshooting issues than one that can't. If they can't, then the only option you have is for the operations people to point at the devs and say, hey, it's your fault. And then the devs are going to point back at them and say, no, it's your fault.
Okay. So then you kind of agree with Louis in that it is actually role dependent, right?
Yeah, it's role dependent. Of course it is.
So you're not a blanket yet.
Okay. So because you're describing it as IT industry,
Mhm.
Like the IT industry has HR people, it has finance people, it has all kinds of people that don't need to know how to code because it has nothing to do with their actual function.
So this crazy mantra of like everybody should know how to code, right, is a little overblown.
It's ridiculous.
Well, so let's talk about HR people and CEOs and VPs for a second. Because now I'm going to ask the question, what do we mean by coding? Because some really complex spreadsheet formulas can be near a database query. It can, especially if it interacts with multiple different spreadsheets or automatically pulls into a slide deck. There are ways for people to put formulas into these solutions to aggregate data automatically. So is that coding or is it not?
Okay, hold on, Chris.
Or is it mathematics?
I don't know.
Maybe everybody needs to be a mathematician.
Or statistics. Is like what you're talking about, Louis, is mainly around reporting, correct?
Right.
Okay, so this is an interesting distinction because I just want to tell the audience that, like, Chris, you melted my brain like a few weeks ago for something that was so ridiculously obvious that is in line with what Louis is talking about. Okay, so what do we mean when we say coding, right? Because we're talking about basically, functional and object-oriented kind of like languages. And then we're talking about basically statistical pieces, right? Or data management pieces like SQL, for example. Some people consider SQL to be coding, right? And then we're talking about Markdown, which that was the part that you melted my brain, Chris, when you were like, well, hold on, operation engineers actually spend most of their time actually just dealing with a DSL, like a Markdown language. They're not actually coding. They're just writing YAML or JSON files and then having them interpreted, right? So to the point then, that the question is all of that programming, or is it just because I think, Louis, the argument of like, hey, it's mathematics, right? I think it's all mathematics somewhere, right? But like, is data manipulation languages, are they programming? Is Markdown programming? And I don't think anyone would disagree that like Python, JavaScript, C++, that is actually, those are the pure, in a sense, programming languages, whatever level they operate at, right? But are the other two programming?
Again, it depends, because like some of the languages that do that stuff get very complex. And in my head anyway, I have always delineated markup versus data manipulation versus programming as being the level of flow control that you have. Right? Okay. In full programming languages, you have full flow control. You can iterate over, series of data. You can jump to other parts of the code, separate things out in functions, have multiple functions called from different places. Like, you have a lot of control over the overall flow of the data going through the system.
Okay.
Whereas something like SQL, it doesn't really have that. Like, it is, each SQL statement is doing a thing. Sure, that thing can get super complex and join a bunch of tables, but you're still just manipulating data. Most markup languages are not actual programming languages because they don't have any flow control. They're just markup. They're a different way to represent an output, right? Markdown, YAML, all of it. It's just a different way to represent the data that's there.
So when you say flow control, I need you to define that for me so that I understand more clearly what you mean by flow control.
So conditionals would generally be considered part of flow control, but that's the one that a lot of languages step into, even if they don't have more advanced or more basically things like loops or, functions being able to separate code out to different spots.
So my mind got blown recently when I saw someone do this. I saw someone in Google Sheets write a script inside of Google Sheets that was literally, it looked like a formula that would go in a cell, and it called out to an API that was part of another application, and it pulled data and it populated a sheet inside this thing and kept it in sync with the data source. So that every time the page was refreshed, it would pull the data from that API and put it into this spreadsheet. Is that coding or is it not?
Yes, that is coding.
So that's what I'm talking about. And this is where I think this conversation gets a little gray. Do you need coding to do these jobs? No, you don't.
No.
But does coding enhance your ability to interact not only with other people within the organization or enhance the outputs of the things that you're able to do? I would say yes. So if that's the underlying question that we're asking here, right? Then I would say yes, everybody should learn a little coding.
Yes.
That's a good point,
Okay.
Louis.
Well,
because you're also saying, in a sense, that all of the principles that you need to learn that could get you to coding could be useful for non-coders, like how to build software, understanding like gates or CI/CD, for example.
Yep.
Like that could
even just how computers think about how data flows, about how databases are built, right? A lot of people don't really realize that a spreadsheet is just a database table, right? That's all it really is. And so, when you have columns and you have rows, guess what? Now you have a database. So you're looking at the database manually, but you could build a script to actually pull the data for you and look at certain fields or combine them or what have you, right? So having that extra level of understanding could enhance your outputs. But for people like product, for people like CEOs, VPs, Scrum Masters, understanding the fundamentals of how technology and data and software functions, what is an if statement, how do loops work, all this other stuff. If you have that knowledge, you lack the syntax of the programming language that's going on in particular for your team, but you understand the basics, it can actually help you understand what limitations the software might have or how the teams might solve these problems, right?
Mm-hmm.
Which can shortcut some of these problems. Like, so if we're trying to eliminate dependencies and try and make sure that everything is as streamlined as possible so teams can deliver, if a product manager understands the architecture of the application and knows what limitations exist, they can request better features and potentially even suggest in software enabling pieces to the teams that will allow for future evolution of the application without the teams having to evaluate and blah, 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 blah at such a deep level that it's like a black box to the product people, right? So that's an enhancement. Is it required? If that's again, we come back to that. Is it a requirement for the job? No. But if you have those skills, I would say you're probably better at your job and better able to serve your customer, which includes the team in this case, right? The product manager serving their customer, the team, to give them better work to actually enhance the output that they're going to give, and serving the company better by enhancing the flow of things and reducing dependencies. So
what I'm hearing, it sounds like we're all in agreement. First of all, whether you need it or not is very much role dependent. Whether it will help you in your role, it sounds like almost across the board, and again, it would vary by role, some level of understanding of software principles all the way up to the ability to do some measure of appropriate coding, whether it's a markdown, a data manipulation language, or a full-blown object-oriented language. Seems like that would still be helpful for a tech career.
Yeah, I agree.
Yeah.
Okay, so then let's go back to, Chris, to something that you said earlier. You said that flow control you felt like was one of the distinguishing markers, right? And then, of course, there's levels to that because we just, mentioned Markdown, we mentioned data manipulation, we mentioned object-oriented. We obviously know there's flow control in full-blown languages. Louis just highlighted the fact that data manipulation languages also have measures of flow control to them, right? So conditionals, loops, all that stuff. Here's a question for you. Do our modern Markdown tools, do they contain flow control? Like, for example, Ansible or Terraform, right? I would argue that Ansible is pretty much Python-based, so it's a little different, right?
Yeah.
Okay. So then what about Kubernetes? What about Terraform? What about the ones that have HCL, for example, the HashiCorp's domain-specific?
HCL has parts of what would be considered flow control, right? You can...
the one I've ever seen is the ternary operator that's conditional, right?
Yes, right. It has conditionals for sure.
Modules, right?
It has conditionals. It almost has loops in the ability to use counter for each and basically create multiples of a particular resource. But it's really limited. And part of that is because it's a declarative language. Like, the whole purpose of it is to express the desired state of infrastructure, not how to get there. And the flow control is needed for the how to get there part. And so Terraform's entire thing was to try to pull a lot of that flow control back into the APIs and the providers, right? To kind of abstract that away from what you actually have to deal with on a day-to-day basis.
So that would be more on the
imperative,
imperative side of things, is what you're saying.
Yeah. Yep.
Yeah. The one where you're like, here's the recipe versus I want a cake.
Exactly. Yes.
Okay. Gotcha. All right. So then let's go back though, because Louis pretty much focused on the entire organization. You've got more of the software and the operations side. I pretty much got more of the operations and the architecture side. So, you made an interesting statement. You were like, hey, operators, whether they're DevOps or sysadmins or SRE, whatever, platform engineers, whatever we're calling ourselves nowadays. And don't get me wrong, we can talk about the distinctions of those roles, but generally, people who create infrastructure that other people are going to use, right? And they support that infrastructure. You said, hey, if you're in an operations role, you end up needing to code because you end up getting basically bad code from the software developers. That's kind of what you said. Am I mangling that too badly?
I said it, earlier today, even that very often it is operations that catches the bugs because, the first time that a bug appears a lot of times is when it has, millions of people visiting it and doing stuff that the testers or the devs didn't think about. And so the first person, on the incident for that is going to be the operations person. The more that they have the ability to dig into the code and figure out what changed and what might possibly be going on, the quicker the incident's going to get resolved, the easier the devs are going to have it to actually fix the bugs that are there. Yeah. And, it solves the problem of devs being able to say, well, I do that same thing and it works on my machine because it's not being hit by a million people.
All right. So I have to say this, though, is that we were with a client and Louis advocated, and I've heard this many times from Louis, and I agree with it, right? Louis, you said, hey, if you ran a cross-functional team, you, for example, might get testing earlier in the upstream cycle so that you wouldn't necessarily have to push it off to another team where it's a bigger problem later on, right? And so, Chris, just to say this, and Louis, I want to hear your perspective on this. It sounds like that's a symptom of a culture that allows that kind of thing where there aren't cross-functional teams, right? And so you're having to pick up the slack. And so it kind of validates the statement that we made earlier about well, coding will help you in whatever role you're in, but particularly if you're on the receiving end of code. But Louis, you were advocating cross-functional teams. In this case, would it be worthwhile to put the developer on call and have them fix the problem? Probably quicker, faster, better than having the operations person be on point.
Well, there's a couple problems there. One is if you're in a software organization and you have a team of developers and QA people, and I'm just going to use Scrum because it's the most popular format, right? So you have a Scrum team and they have a dedicated sprint that they're trying to execute on. If a problem appears on the live application, then if someone gets pulled from the team to work on that problem, then their schedule gets ruined, frankly. Now, a lot of good Scrum Masters and product owners will help to try and mitigate some of that possibility by only planning towards 80% of the velocity of the team so that way, as things pop up, they have space to take care of things. But if it's a big problem, if the whole team diverts, now the schedule is completely blown out of the water, right? So, yes, you want to move testing to the front end of the thing, right? There's no such thing as a QA team that the developers are writing code and tossing things to a QA team. That doesn't exist anymore. Now we're doing TDD or BDD, where the testing is happening up front, right? You're writing tests before you actually write any code. Then the code gets written. But we also have to take into account, Michael, the human factor. People are going to create bugs. Code is complex, especially for large applications, and things are going to cause problems. So if your safety net, which is your operations team, has no experience with code and they have to come back to the developers to fix problems, the only way I have seen this successfully work, if the operations team are not allowed to touch the code, They don't have the skills to touch the code. They can't do any of that stuff. The only way I've seen this work is that there is, for either a single application or multiple applications, there is a triage team. They're familiar with the code base. They are not a sprint-based team. They're more of a Kanban-style team that can change what they're doing based on emergency. And they are the team that works with operations. When a bug is found in operations, the operations team works with the triage team of developers to solve this problem in a very fast manner. Code gets pushed into the main branch. Things get updated and so on and so forth. And things move on. So that way your sprint teams are not interrupted. That can work, but it really depends on the organization, your people, your skills, etc. If the operations team is empowered to do some of it, there's also potential problems that can happen there. Sometimes there's bad actors who have access to the code base who go in and make changes that they think are appropriate, which really screws up everything in the code base for the people who are currently in the middle of the sprint. And now suddenly something that they're writing no longer works, and they don't realize it until they try and push something. Like, there's all kinds of dynamics where problems can exist here. It's really just about trying to figure out how to mitigate the problems within your specific culture. So it's hard to answer that with a definitive answer, Michael. Sorry about that.
No, I think that's appropriate, right? Go ahead, Chris.
There's one thing you said there that I'm not sure I agree with as being a good thing. And that's this idea that sprint teams shouldn't be interrupted.
That's one of the fundamentals of Scrum, man, is that once the sprint is set, you can't change it.
Well, then perhaps Scrum is stupid. Because and this depends. If the idea is to just put out features, sure, fine, don't interrupt the sprint. If the idea is to put out a quality product, then that should be more important. And if there's a bug, it's got to get fixed.
So,
right?
So the way that Scrum should work, right, in this particular instance, right, is a sprint is planned. Normally, again, you plan to 80% of the team's velocity so that they have 20% of their productivity that can be diverted to either making new cool stuff, pulling things that would go into the next sprint to work on to try and squeeze it in, or solving problems like this bug that was found, right? If it's not a application breaking, horrible bug that brings all the servers down, what happens is that bug goes into a backlog, which then gets pulled into a sprint as part of a sprint to deliver a fix, right? That's how that works. So if we're talking about show-stopping emergency bugs, that's a different story. That's where you might need operations people to fix things or a triage team to fix things. But if it's something that, okay, this isn't working the way it's intended, we can wait until the next sprint to resolve this bug, it goes into the backlog for the team, and the team ingests it. The reason why, in specific, Scrum does not want interruption is because they don't want to delay what they have promised to the organization they're going to deliver, right? And that's part of the intent of Scrum. You promise that you're going to deliver these features or these increments, and you deliver them. If you keep getting derailed, like some of the clients that Michael and I have worked with, where emergencies trump the delivery of new features, then your application quickly stops delivering value because all you're doing is chasing problems that may even just be perceived problems and are not necessarily even on your roadmap for real, right? And so that's a problem. But that's not what this episode is about, right? But
right,
yeah,
sure,
yeah. But I mean, appropriate, I think, because what you're saying basically is that if there's a culture that says, "Hey, we're just going to push this downstream to the operations folks," then learning how to code is a position that they're forced to be in because they're receiving basically a product that they have to fix.
Yep.
So, like, if you're getting woken up at 3:00 in the morning, you're going to learn how to fix it, right?
And that's why most operations teams have to reserve 50 or even 60 or more of their time to deal with bugs, to deal with outages, to deal with stuff that comes up because nobody else is going to look at it.
Well, and it's funny because, I mean, we could easily have a whole thing about the interrupt-driven versus the kind of product-driven focus, right? So, I mean, unfortunately, when you are responsible for keeping the system alive and you're the front line for that, the system always trumps every priority, unfortunately, right? Unless you get really good at creating resiliency. And I think most shops are just not good at that, right?
Right. But I agree with that statement that this, the system reliability should trump everything, but it doesn't in the case of a sprint team. And that's what I was complaining about, or that's what I was disagreeing with.
But there's a mechanism to deal with that, obviously, right? If you're doing it appropriately. I think the challenge, and I don't mind us talking about this, just to be clear, is that, I mean, at least in my experience, is that most people don't either follow or read the known good practices for these things that have been looked at and talked about for the last 20 years. And, I'm going to make a bombastic statement that anecdotally seems remarkably true. Most people don't read or follow the kind of management or the flow of work through a system. And so, like, when we talk about software development, people are like poo-pooing like Agilists and other people whose main jobs is to get value out of a system that has a lot of moving pieces and components. And it's funny because, like, if you read like the goal or talk about the theory of constraints, it's like you're going to run a system at somewhere between 50 to 60%, maybe 70% capacity, to Louis' point, so that you can have the flexibility to deal with your constraints, your bottlenecks, your issues, and all the variability that arises. And it's like, but like companies don't do that. It's always balls to the walls, run the team at 110%. I mean, even this 996. Have you guys seen this 996 thing happen in Silicon Valley?
No.
So people are working like 80 hours a week, 6 days a week, just running it down, and then they're like, if you don't like it, get out, basically. And I'm like, well, hold on. After 1, 2, 3 weeks of running, let's just say at a minimum of 80 hours, I thought we studied this. I thought this had been studied, that capacity starts to go down, cognitive capability starts to go down, quality of work starts to go down, and that your recovery time is usually 2 or 3 times the amount of time that you spent running at that overcommit.
Yep. 100%. Right? That is a massive problem. There is a human exhaustion factor, right? Even people who are excited about it will eventually start to burn out. And there is a whole movement about sustainable pace. This is probably a whole other thing we could talk about, is building your teams and your organization to operate as a sustainable pace. But I mean, to come back to the topic of the podcast for a second, some of these problems, right, I think could be eliminated by people brushing up on a certain level of coding knowledge, computer knowledge, tech knowledge that would push them a little beyond their specific role, right? By understanding, again, we use the product manager example, by understanding how the application is architected, how the databases function, what are the limitations of the way that the application can query the data? What are the limitations of the UI? What do we currently exist in? So instead of being a person who is throwing wishes at a leprechaun, right, and saying, I want the application to do this by 2 weeks from now, that's not realistic. The more that a product owner can understand those limitations, the guardrails, the intricacies of the application, the better their designs for the application, their feature requests, their stories can be codified so that the team doesn't have to spend as much time reviewing them. They don't have to spend as much time picking them apart, and they can spend more time delivering value, even potentially emergent ideas that happen from the team that improve the product beyond what the product manager has asked for. So by having that little bit of coding knowledge, you can accomplish that. Salespeople, even, who are going out and selling an application and understanding the limitations of the technology, why the application does things one way over another way, like those types of things, especially if you're working in software that is marketing to businesses that, may improve a function within a technology team. A salesperson understanding the technology, not just for what the application does, but the underlying way the application works, right, will help them sell better, right? Yeah. CEOs and VPs that manage people who understand how these things operate can look at a sprint board and say, oh, this is why we're having problems with this story or this feature, and the reason why it keeps getting delayed, rather than pushing them to 60 hours. So understanding at least I would say a surface level technical understanding, rather than deep diving into syntax for specific languages, right, I think enhances everyone's ability to contribute and an organization. But is it a requirement on a job posting? Likely not.
Okay, fair enough. Because also I want to make a distinction here is that, Chris, you said earlier that Markdown was more declarative oriented, so therefore less flow is required unless you want to force it in, right? Data languages, right, are mainly about data manipulation. So most of their functions relate to pulling in data, presenting data, grouping data, sorting data, right? And then, of course, the full OO languages are full algorithmic expressions. So they are fully mathematical on all fronts and have all operators for the most part. Like they are fairly similar.
Yes.
I guess the thing here, though, to go back to this is that, one, it sounds like we all acknowledge that there is tremendous value for almost any role to learn at least software principles, if not the ability to at least read some measure of markdown, data manipulation, or programming, again, depending upon your role. Like, it doesn't sound like any of us are arguing that. There's value in it. Yes? No,
Yeah, I would agree.
Okay. All right. So then the other thing that's interesting, though, is that then there are cultures, it sounds like, because Chris highlighted this, where roles that traditionally wouldn't learn full feature programming have to, because the culture, the people, the process, the organization, the flow, the technology has made it so that this role has to do it because they haven't, for lack of a better word, figured out how to move that upstream to the source of the generation.
Michael, are you talking about product managers who are doing AI vibe coding on their own? Is that what you're talking about? Is that what you're talking about?
Yeah. Give me a minute and we will get there.
Okay.
Because this leads to the next question, and probably the last question for the topic is, so I am doing a lot of work in the education space, and we have very vigorous discussions about what's going to happen in the next 3 to 5 years, it being 2025. And so the argument I'm getting from people is we don't need to learn how to code at all anymore. Let's just because implementation is going to get eaten by the machine. So let's let them, let me finish. Is that, machine's going to eat it. Machine's going to be better at it. Machine's going to be so good at it that we don't need to understand not only software engineering principles, but we don't need to know how to do implementation. So we might learn some of the software engineering principles. Here's my counter argument to that. And then you guys please pop in. I'm like, you can't understand the principles until you've actually done some of the coding. Like, even if you don't go and develop multiple applications over multiple years, if you've never actually coded, you've never seen the principles put into practice, and the principles are there to lead to outcomes. And if you haven't done the translation of principle to outcome, you haven't coded, even if it's just your own backyard application that you've made, if you haven't done it, you don't truly understand how the expertise leads into the experience. And so the counter argument I'm getting is that, well, Michael, the AI is going to do that. I was like, yeah, but who's going to watch? These are supposed to be partners. They're supposed to be assistants. And if they orchestrate an entire system and you can't teach them where they went wrong, even if it's just a general statement about the software principle, like testing, for example, I had Claude Code delete an entire Kubernetes cluster the other day because I didn't follow good software practices. And I gave it direct access to my cluster for a moment in time, and it deleted the whole thing. Is it Claude's fault that it did that? Or is it my fault for not sticking with the GitOps cluster API flow that I had that prevented any bad actor from messing my cluster up? So then the question is for you two is this: do we still need to learn how to code in 2025? I mean, even regardless of role, whether you're learning it for a product role that just enhances your relationship with the developers, or you are a feature developer, do we still need to learn how to code in 2025? Is that going to be useful?
Yes, and I would go even farther and say that anybody that says, oh, you don't need to know how to code, the AI is going to do it, right there, I don't really think they understand it.
Understand what? Coding?
AI in general, or coding, or both.
Okay, say more.
I mean, AI, is like, it is not generating code. It's not thinking about the problem and creating code. It's thinking about the problem, meaning it's taking what you've told it and tried to figure out what you really want. Then it takes that and goes and scours its database of existing code to try and find things that it thinks might solve that problem. It's not writing code. It's not thinking for itself. It's not saying, you know what, I need to get this data from over here. It's literally just going through a bunch of data that it knows of code that has been written before and spitting out something that looks like that.
Okay, so it's probabilistically trying to figure out and generate based on the inputs you've given it.
Yep.
And you mentioned RAG, basically, because if it has access to a database or a document chunk, it's going to use that for context, right? Basically retrieving context, right? Okay. So what you're saying basically is that if we're saying we don't need to code, it's because we don't understand that AI actually is not going to be consistently enough and or creative enough or understanding enough or contextualized enough to develop the code that we need.
Yes. And I think we're already starting to see the limits of LLMs, right? GPT-5 was supposed to be this big jump forward, and it hasn't really shown itself to be. We're seeing that with other versions of the other models. The latest versions of are just not. We're not seeing the big jumps in improvement that we were in the beginning.
Agreed. I've had some bad experiences over the last 48 hours, so I'm not going to make any comments because it really kind of colored my thing. And I'm not talking about cluster deletion events. Just general interaction has been bad across Grok, Perplexity. All of them have pissed me off in the last 48 hours. So no comments there. Louis, what about what do you think? Do we need coding?
So first of all, AI isn't really AI. Chris mentioned that it's calling these LLMs AI is a marketing tactic, and it's working for the most part. But it's not actually really an artificial intelligence. It's not Jarvis that you can talk to that actually can.
Well, it's not AGI. It is AI. It's not AGI.
Sure, but it can't collaboratively work with you to solve a problem. As Chris pointed out, it's going to find other ways that someone else has solved the problem and then put it into your code. And here's my statement, looking at it from a business perspective. All right. And I'm going to use a simple analogy to try and illustrate this point. If you build cars, you might have robots that help you build those cars in your manufacturing plant.
Right.
And in order for that to work, you have to teach those robots exactly what has to happen in order to build those machines. Well, guess what? When you have a manufacturing plant that makes cars, you still have defects. You still have problems. You still have issues. You still have recalls. You still have all these things. And what is that solved by? It's solved by people who understand every bolt, every washer, every chamber on that car, right? And if you remove anyone's understanding of how the car functions, how many screws it's supposed to have, where a plastic bolt is used instead of a metal bolt, like all of this stuff, if you remove that from people and you just make the robots solve it, we're going to be driving cars that fall apart on the road because the robots are not going to make the right choices. They're not going to fix things. They're not going to do it. They're just going to make it look like it's functional, and that's going to be it. And so there's always going to be a need for people to solve the problems that AI is generating because AI is not going to stop generating problems. It might be faster at doing the bulk work, right? But that's just scripting. It's not creative problem solving. It's just scripting. So if you use AI to do the things it's good at, which is to create bulk scripting work or to do a task where things are already defined, you might enhance your speed. But if you remove people's ability to understand and parse the work that the AI has done, you're setting yourself up for long-term failure. And so I think that is really the problem. Can we replace our brains and not worry about coding anymore? I think absolutely not. Because even if we have this agentic world where we're sharing code space with an AI or an LLM that's making these products with us, if we step out of the picture, the product will eventually fall over and we won't know why. And so it's not a good idea.
Yeah, because it's interesting. Like, there's been several kind of recent experiences that kind of highlight this where, Liam came to me recently and he was like, he's 18, so going to college, right? And he said, should I even learn computer science? And it's interesting because I was like thinking about I love to read like trashy sci-fi and fantasy novels as well as the good ones, right? And in one of them, like one of the like space operas, like the sci-fi ones, when the Marines went in for basic training, because it was like a military one, they all had like augmented reality, like computers, like comps in their brains. And when they went into basic, they disabled them and forced them to learn how to memorize, move, assess. Like they like forced them to redo all fundamental skills with no assistance. So then when they had those fundamental skills and the assistants came in, they were so much better, right, than they were. And especially if something happened, like, it was disrupted or they didn't have access to it for whatever reason, right? And so, like, I told Liam, I said, well, what's funny is that it might be true that you might be working with a bunch of AI agents who, in a sense, are better at coding in many ways from a documentation and a consistency standpoint if they've seen it before. I said, but if you haven't done the work to build that together, and then you're applying the general architectural principles and you're running the strategy and you're running the creative and the quality control and all the other stuff, I was like, the general idea is that we're trying to get to as much automation as possible because human beings are fallible. But I want to highlight something, Chris, that you implied that we didn't label. The AGI, the current Gen AI stuff that we have is probabilistic.
Right.
The reason my cluster got deleted is that the deterministic guardrails that I used to prevent that cluster from getting deleted, I allowed the AGI to go around those deterministic guardrails. And what did it do? Almost immediately, the first time it had access to the cluster, by the way, just in case you're curious, it did a force fresh overwrite on the etcd database that contains the entire configuration and just deleted everything. By the way, this was 5 months worth of work. And so what was interesting is that the deterministic guardrails were there to prevent any bad actor from doing the very thing that once it had unfettered access, it did. Now, I'm not labeling it negatively. It was trying to actually be helpful. But my point being is that who's going to lay those deterministic guardrails? Who's going to look at the strategy? Who's going to do all that work? Human beings are probably going to lay those guardrails because with the current state of LLMs, we're not going to get away from probabilistic outputs compared to the deterministic outputs that we get even with software, which you, Louis, just made a statement that we generate bugs even when using deterministic guardrails. We generate bugs because of these complex systems. So I agree. I think that we should be, in a sense, for me, we would go back to Harvard's entrance exam in like 1880, where you had to memorize, like good pieces of work, do mathematics. Like the other day, Liam came to me and he goes, "Hey, Dad, do you know what the powerhouse of a cell is?" And I was like, "Yeah, it's the mitochondria." And then he goes, "I didn't write a thing on it." And he was like, "Do you know something about it that most people don't know?" I said, "It has DNA." And he was like, "What?" I was like, "It has matriarch like DNA, like you get it from your mom." And he was like, "What? They didn't teach us this in school." Right. And it was like, next thing you know, he's doing a whole paper on it. He's talking about the whole thing. And it's like, how do you remember this? And it's like, because we learn these general principles and these concepts thinking that they are not going to be applicable. But it's like, they are applicable. So to me, getting hands-on and learning how to code, I think is one of those essential tasks that takes the principles and makes them real. So argument's still out, but what I'm being told now is that from an education perspective, in 5 years, we're going to go to the AI and say, "Okay, can you generate a complete video on demand course for Kubernetes and tell me all about it?" And I'm like, but it's still not going to be able to answer your questions. It's still not going to be able to predict the things that you need to know. And is it going to be able to contextualize that for a business? So, okay, cool. Well, let's call it there. I appreciate this. This was a good discussion. And we will catch you guys next week in our next episode. So.